Sapiens, A Brief History of Humankind by Yuval Noah Harari, narrated by Alisha. An animal of no significance, skeletons in the closet. Homo sapiens has kept hidden an even more disturbing secret. Not only do we possess an abundance of uncivilized cousins, once upon a time we had quite a few brothers and sisters as well. We are used to thinking about ourselves as the only humans because for the last 10,000 years our species has indeed been the only human species around. Yet the real meaning of the word human is an animal belonging to the genus Homo, and there used to be many other species of this genus beside Homo sapiens. Moreover, as we shall see in the last chapter of the book, in the not so distant future, we might again have to contend with non-sapiens humans. To clarify this point, I will often use the term sapiens to denote members of the species Homo sapiens, while reserving the term human to refer to all members of the genus Homo. Humans first evolved in East Africa about 2.5 million years ago from an earlier genus of apes called Australopithecus, which means southern ape. About 2 million years ago, some of these archaic men and women left their homeland to journey through and settle vast areas of North Africa, Europe and Asia. Since survival in the snowy forest of northern Europe required different traits than those needed to stay alive in Indonesia's streaming jungles, human population evolved in different directions. The result was several distinct species, to each of which scientists have assigned a pompous Latin name. Humans in Europe and Western Asia evolved in Homo neanderthalensis, man from the Neander Valley, popularly referred to simply as Neanderthals. Neanderthals, bulkier and more muscular than us sapiens, were well adapted to the cold climate of Ice Age Western Eurasia. The more eastern region of Asia were populated by Homo erectus, upright man, who survived there for close to 2 million years, making it the most durable human species ever. This record is unlikely to be broken even by our own species. It is doubtful whether Homo sapiens will still be around 1,000 years from now, so 2 million years is really out of our league. On the island of Java in Indonesia lived Homo solensis, man from the Solo Valley, who was suited to life in the tropics. On another Indonesian island, the small island of Flores, archaic humans underwent a process of dwarfing. Humans first reached Flores when the sea level was exceptionally low and the island was easily accessible from the mainland. When the seas rose again, some people were trapped on the island, which was poor in resources. Big people who need a lot of food died first. Smaller fellows survived much better. Over the generations, the people of Flores became dwarfs, the unique species known by the scientists as Homo florescensis reached a maximum height of only 1 meter and weighed no more than 25 kilograms. They were nevertheless able to produce stone tools and even managed occasionally to hunt down some of the island's elephant, though, to be fair, the islands were a dwarf species as well. In 2010, another lost sibling was rescued from oblivion when scientists excavating the Denisova cave in Siberia discovered a fossilized finger bone. Genetic analysis proved that the finger belonged to a previously unknown human species which was named Homo denisova. Who knows how many lost relatives of ours are waiting to be discovered in other caves on other islands and in other climes. While these humans were evolving in Europe and Asia, evolution in East Africa did not stop. The cradle of humanity continued to nurture numerous new species such as Homo rudolfensis, man from Lake Rudolph, Homo ergaster, working man, and eventually our own species, which we have immodestly named Homo sapiens, wise man. The members of some of these species were massive and others were dwarfs. Some were fearsome hunters and other meek plant gatherers. Some lived only on a single island while many roamed over continents, but all of them belonged to the genus Homo. They were all human beings. It's a common fallacy to envision this species as arranged in a straight line of descent, with Ergaster begetting Erectus, Erectus begetting the Neanderthals, and the Neanderthals evolving into us. This linear model gives the mistaken impression that at any particular moment only one type of human inhabited the earth and that all earlier species were merely older version of ourselves. The truth is that from about 2 million years ago until around 10,000 years ago, the world was home at one and the same time to several human species. And why not? Today there are many species of bears: brown bears, black bears, grizzly bears, polar bears. The earth was once walked by at least 6 species of man. It's our current exclusivity, not the multi species past, that is peculiar and perhaps incriminating. As we will shortly see, we sapiens have good reason to repress the memory of our siblings. The cost of thinking. Despite their many differences, all human species share several defining characteristics. Most notably, humans have extraordinarily large brains compared to other animals. Mammals weighing 60 kilograms have an average brain size of only 200 cubic centimeters. The earliest man and woman 2.5 million years ago had brain of about 600 cubic centimeters. Modern sapiens sport a brain averaging 1200 to 1400 cubic centimeters. Neanderthal brains were even bigger. That evolution should select for larger brains may seem to us like, well, a no-brainer. We are so enamored of our high intelligence that we assume that when it comes to cerebral power, more must be better. But if that were the case, the feline family would also have produced cats who could do calculus, and frogs would by now have launched their own space program. Why are giant brains so rare in the animal kingdom? The fact is that a jumbo brain is a jumbo drain on the body. It's not easy to carry around, especially when encased inside a massive skull. It's even harder to fuel. In Homo sapiens, the brain accounts for about 2-3% of total body weight, but it consumes 25% of the body's energy when the body is at rest. By comparison, the brain of other apes require only 8% of the rest time energy. Archaic humans paid for the large brain in two ways. Firstly, they spent more time in search of food. Secondly, their muscles atrophied. Like a government diverting money from defense to education, humans diverted energy from biceps to neurons. It's hardly a foregone conclusion that this is a good strategy for survival on the savannah. A chimpanzee can't win an argument with a Homo sapiens, but the ape can rip the man apart like a rag doll. Today, our big brains pay off nicely because we can produce cars and guns that enable us to move much faster than chimps and shoot them from a safe distance instead of wrestling. But cars and guns are a recent phenomena. More than 2 million years ago, humans' neural networks kept growing and growing, but apart from some flint knives and pointed sticks, humans had precious little to show for it. What then drove forward the evolution of the massive human brain during these 2 million years? Frankly, we don't know. Another singular human trait is that we walk upright on two legs. Standing up, it's easier to scan the savannah for game or enemies, and arms that are necessary for locomotion are freed for other purposes like throwing stones or signaling. The more things these hands could do, the more successful their owners were. So, evolutionary pressure brought about an increasing concentration of nerves and finally turned muscles in the palms and fingers. As a result, humans can perform very intricate tasks with their hands. In particular, they can produce and use sophisticated tools. The first evidence for tool production dates from about 2.5 million years ago. and the manufacture and use of tools are the criteria by which archaeologists recognize ancient humans. Yet walking upright has its own downside. The skeleton of our primate ancestor developed for millions of years to support a creature that walked on all fours and had a relatively small head. Adjusting to an upright position was quite a challenge, especially when the scaffolding had to support an extra large cranium. Humankind paid for its lofty vision, an industrious hand with backaches and stiff necks. Women paid extra. An upright gait required narrower hips constricting the birth canal, and this just when babies' heads were getting bigger and bigger. Death in childbirth became a major hazard for human females. Women who gave birth earlier when the infant's brain and head were still relatively small and supple fared better and lived to have more children. Natural selection consequently favored earlier births, and indeed, compared to other animals, humans are born prematurely. When many of their vital systems are still underdeveloped, a colt can trot shortly after a birth. A kitten leaves its mother to forage on its own when it is just a few weeks old. Human babies are helpless, dependent for many years on their elders for sustenance, protection, and education. This fact has contributed greatly both to humankind's extraordinary social abilities and to its unique social problems. Lone mothers could hardly forage enough food for their offspring and themselves with needy children in tow. Raising children required constant help from other family members and neighbors. It takes a tribe to raise a human. Evolution thus favored those capable of forming strong social ties. In addition, since humans are born underdeveloped, they can be educated and socialized to a far greater extent than any other animal. Most mammals emerge from the womb like glazed earthen were emerging from a kiln. Any attempts at remolding will only scratch or break them. Humans emerge from the womb like molten glass from a furnace. They can be spun, stretched, and shaped with a surprising degree of freedom. This is why today we can educate our children to become Christian or Buddhist, capitalist or socialist, warlike or peace loving. We assume that a large brain, the use of tools, superior learning abilities, and complex social structures are huge advantages. It seems self evident that these have made humankind the most powerful animal on earth. But humans enjoyed all of this advantage for a full 2 million years, during which they remained weak and marginal creatures. Thus, humans who lived a million years ago, despite their big brains and sharp stone tools, dwelt in constant fear of predators, rarely hunted large game, and subsisted mainly by gathering plants, scooping up insects, stalking small animals, and eating the carrion left behind by other more powerful carnivores. One of the most common use of early stone tools was to crack open bones in order to get to the marrow. Some researchers believe this was our original niche, just as woodpeckers specialize in extracting insects from the trunk of trees. The first humans specialized in extracting marrow from bones. Why marrow? Well, suppose you observe a pride of lions take down and devour a giraffe. You wait patiently until they are done. But it's still not your turn, because first the hyenas and jackals, and you don't dare interfere with them, scavenge the leftovers. Only then would you and your band dare approach the carcass, look cautiously left and right, and dig into the edible tissues that remain. This is a key to understanding our history and psychology. Genus Homo's position in the food chain was until quite recently solidly in the middle. For millions of years, humans hunted small creatures and gathered what they could, all the while being hunted by a larger predator. It was only 4 lakh years ago that several species of man began to hunt large game on a regular basis, and only in the last 1 lakh years, with the rise of Homo sapiens, that man jumped to the top of the food chain. That spectacular leap from the middle to the top had enormous consequences. Other animals at the top of the pyramid, such as lions and sharks, evolved into the position very gradually over millions of years. This enabled the ecosystem to develop checks and balances that prevent lions and sharks from wreaking too much havoc. As lions became deadlier, so gazelles evolved to run faster, hyenas to cooperate better, and rhinoceros to be more bad tempered. In contrast, humankind ascended to the top so quickly that the ecosystem was not given time to adjust. Moreover, humans themselves failed to adjust. Most top predators of the planet are majestic creatures. Millions of years of dominion have filled them with self confidence. Sapiens, by contrast, is more like a banana republic dictator. Having so recently been on one of the underdogs of the savannah, we are full of fear and anxieties over our position, which makes us doubly cruel and dangerous. Many historical calamities, from deadly wars to ecological catastrophes, have resulted from this over hasty jump. A race of cooks. A significant step on the way to the top was the domestication of fire. Some human species may have made occasional use of fire as early as 8 lakhs years ago. By about 3 lakh years ago, Homo erectus, Neanderthals, and forefathers of Homo sapiens were using fire on a daily basis. Humans now had a dependable source of light and warmth, and a deadly weapon against prowling lions. Not long afterwards, humans may even have started deliberately to torch their neighborhoods. A carefully managed fire could turn impassable barren thickets into prime grassland teeming with game. In addition, once the fire died down, Stone Age entrepreneurs could walk through the smoking remains and harvest charcoal, animals, nuts, and tubers. But the best thing fire did was cook. Foods that humans cannot digest in their natural form, such as wheat, rice, and potatoes, became staples of our diet thanks to cooking. Cooking killed germs and parasites that infested food. Fire not only changed food's chemistry, it changed its biology as well. Humans also had a far easier time chewing and digesting old favorites such as fruits, nuts, insects, and carrion if they were cooked, whereas chimpanzees spend 5 hours a day chewing raw food. A single hour suffices for people eating cooked food. The advent of cooking enabled humans to eat more kinds of food, to devote less time to eating, and to make do with smaller teeth and shorter intestines. Some scholars believe that there is a direct link between the advent of cooking, the shortening of the human intestinal tract, and the growth of the human brain. Since long intestines and large brains are both massive energy consumers, it's hard to have both. By shortening the intestine and decreasing their energy consumption, cooking inadvertently opened the way to the jumbo brains of Neanderthals and sapiens. Fire also opened the first significant gulf between man and other animals. The power of almost all animals depend on their bodies, the strength of their muscles, the size of their teeth, the breadth of their wings. Though they may harness winds and currents, they are unable to control these natural forces and are always constrained by their physical design. Eagles, for example, identify thermal columns rising from the ground, spread their giant wings, and allow the hot air to lift them upwards. Yet eagles cannot control the location of the column, and their maximum carrying capacity is strictly proportional to their wingspan. When humans domesticated fire, they gained control of an obedient and potentially limitless force. Unlike eagles, humans could choose when and where to ignite the flame, and they were able to exploit fire for any number of tasks. Most importantly, the power of fire was not limited by the form, structure, or strength of the human body. A single woman with a flint or fire stick could burn down an entire forest in a matter of hours. The domestication of fire was a sign of things to come.